Okay, I'm going to work through each of the problems on the review. Again, if you're confident with the first page, you could skip into the video a little bit further. This will help you in preparation for your exam. So as we said before in class, the first page is the format of the test. So you'll notice there's some short answers, some multiple choice. The question is off to the left. You will put your answer in the answer box in the corresponding spot on the right. So let's just work through this. The first one is related to absolute value functions. Given the equation y equals 3, absolute value of x minus 4, subtract 1, and we are going to first graph the function. Remember we talked about the parent function sits at the origin at 0, 0, so everywhere when we plot this graph, we move it from there. We know that this -1 right here is going to move the vertex down 1. This value right here will move it to the right 4. This right here is going to stretch and create a slope of 3 over 1, right? So this is going to stretch it vertically by 3. So when we graph this again, we're going to go to the right 4, we're going to go down 1, and that's where our vertex moves away from the origin. And then we have a slope of 3, so I'm going to go up 3 over 1. And I go in both directions because we know that absolute value graphs make a V. Oh, pretend that's a straight line. Once you have that, then you're going to identify the different parts. So part B asks us to state the domain. Remember, the domain are the x values for which the function exists. On our graph, there's arrows going in both directions, right? Negative infinity to infinity. All real values work in this function. And the range is the y values for which it works. So if we think about our y values, notice the graph doesn't exist down here in these y values. The first y value that actually exists for our function is -1, and then it goes up forever. So we're going to write our range as -1 with a bracket, and it's going to go up to infinity. Or some of you guys like to write it as y is greater than or equal to -1. That's great too. The vertex is the point at which the function makes a V. So this point right here on the graph, that's the point for -1. So we write that as a point for -1. Part E just asks you to list the transformations. So remember, we already kind of listed them up at the top when we graphed it. But there's a shift, or we could call it a translation, down 1. It goes to the right 4. So we just need to be specific. And then there's a vertical stretch of 3. Okay. Number 2, identify the solution for the equation. So this one you're solving an equation. So just remember, when we solve an equation, we'll go ahead and distribute the -5. We get -35n. -5 times -5 is +25. And we've still got the -29 minus, not a 2, 8n on the other side. And then we want to put all the variables on one side. So if we want to move something across an equal sign, then we do the opposite to add to 0. So if that's a -35n, I want to add 35n. That cancels. Then I can add the same thing on the other side. Okay, same thing with our other values. If I want to move the 29 to the other side and it's negative, I add 29 so that I can move it to the left side. That leaves me with 54 on the left, and a -8n plus 35 is 27n. Then we keep solving for that variable by dividing by 27, and if we divide 54 by 27, we get n is equal to 2. Looking at our multiple choice options over here, that would be B, so in our answer box to the right, we would put the letter B. Number 3, state the sets of the number system -7 is a part of. Remember our number system when we started to draw it. On the inside was the natural numbers, right? No negatives yet. The next one was the whole numbers. The next one was the integers. So this is where negative numbers would start to fit in. So we're going to start with integers, and then as we worked our way out, the next one out was rational, and then real and complex. Again, draw out that number system. That's our last question on the quiz if you need to review that. Number 4, classify the following polynomial that says B, by degree and number of terms. There's 3 terms here, 1, 2, 3, so we know it's a trinomial, so it's not B or C. And then we look at this. This is a degree of 2, which makes it quadratic instead of linear, so that would be A. Moving to the second page, again, these are graphing absolute value functions, so I'm going to go through this kind of quickly. But again, we base this off of movement from the origin. So if it were to start at the origin with a slope of 1, right? However, this is going to change. So it looks like we're going to go up 4. And it looks like this negative is going to flip it upside down, right? It's called a reflection. So we're going to move this up 4. Doesn't go to the right or left at all. And then we have a slope of 2. It's been stretched by 2. So we're going to go down 2 over 1 so that it opens down. And then we can connect our dots to create our V. The domain, again, on these is negative infinity to infinity. All real numbers work on our absolute value functions. The range, this time the range is down here in the negative values. So we're going to go from negative infinity, right? We go least to greatest, and then it looks like we stop at positive 4. So our range is going from negative infinity up to 4. Or again, for those of you that like the inequality, you could write it as y is always less than or equal to 4. The vertex, again, that point at which it's making a V, is up there at 0, 4. And the transformations, we listed them at the top. That negative means that there's a reflection, right? It's opening down, so reflection over the x-axis. It's shifted up 4. And then there was that vertical stretch of 2. On to the right, again, same idea. So we're stretching it again right here. This moves it right or left, and it always goes the opposite of what it looks like. So this is moving to the right 2, and this one is going up 3. So we're going to move that vertex up 3 to the right 2, and it's going to sit right there. And then we're stretched with a 2, meaning this one's opening up, and we're going up 2 over 1, up 2 over 1 to create our V. Okay, again, the domain, negative infinity to infinity, all real numbers work. Our range on this one, it looks like our graph is not down here, so we are starting at 3 and then we're going up forever. So we're going to say 3 to infinity with a bracket on 3, or again, if you like the inequality notation, y is always greater than or equal to 3. The vertex there, that point at which it's making the V, right, is over 2 up 3. And the transformations, again, it's shifted or translated up 3, right 2, and stretched vertically by 2. Okay, absolute value functions. Okay, jumping down, this is more solving. So I'm going to solve a couple of these. Again, you can then check the other two maybe with the key. We're just going to look through a couple of these ones. And they all have some sort of parenthesis related to them, so you're going to start there. So if I start with this first one, we distribute that negative 7 in, we get negative 42. Negative 7 times negative 2k is positive 14k. And then we just bring the rest down. Again, if we want to move something across the equal sign, say I want to add 42 to move it over here with the other like term. And maybe I could move my 6k to the left, so I subtract it and move it to the left. In which case we have 8k on the left and we have a positive 40 on the right. Then we divide both sides by 8 and k ends up equaling 5. Now remember, on our number systems, 5 is one of the natural numbers at the middle, so if it's natural, it's also a whole number. It's also an integer. It's also rational. And then we're moving all the way out of our number system to real and complex. Okay, let's do one more of those. I'm going to jump over to number 8. So again, we're going to distribute first, and we're going to end up with 18n. 6 times negative 3 is negative 18. And we've got negative 38 plus 8n on the left side of the equal sign. Again, we're going to move things across the equal sign, so I'm going to subtract 8n to combine my n values, as well as add 18 to move it to the left. When we do that, negative 38 plus 18 is a negative 20, and 18n minus 8n is 10n, so we divide by 10, and n is equal to negative 2. Negative 2 is an integer, right? It's a negative value, so we start with integers, and then go to rational, and then real, and complex. Okay, 9 and 10 are very similar. Just keep track of those negatives as you distribute through. For 11 through 14, we're asked to write the polynomial in standard form. Remember, standard form means we take the term with the highest exponent, and it gets to go first, and then the terms decrease by exponents as we move. Then we're going to identify the degree. The degree is the highest exponent in all of our polynomial. And the leading coefficient, once we put it in standard form, is the number in front of the polynomial. And then we'll classify it just by how many terms it has. So let's start by putting these in standard form. Again, if we look at number 11, we have 6 plus 2x squared. 2x squared has an exponent of 2. 6 doesn't have a variable, so it goes second. Okay. That one right there, then its highest exponent, or its degree, right? We call it a degree, would be 2. The leading coefficient is the number out front of our polynomial, so that would be a positive 2. And because there are 2 terms involved, we call this a binomial. Moving to the next one, notice 5p to the 6th, is the highest exponent. Then we would put the negative 3p cubed, its exponent is 3. And then the negative 4 that has no exponent or variable comes at the end. So the degree is the highest exponent, which in this case would be equal to 6. The leading coefficient is the number leading our polynomial in standard form, which is a 5. And there are 3 terms in this one, so we call it a trinomial. Following those same processes, in the next one, looks like 7 is the highest exponent, so 9x to the 7th goes first. The next biggest one is x to the 5th with the 13, so it gets to go second. And then the negative 6x squared would bring up the rear. The degree here is the highest exponent, so again the degree here is 7. Leading coefficient, the number that leads the polynomial when it's written in standard form. And since there are 3 terms, this one is also a trinomial. Okay, and we can move this last one. Again, we're going to have 8y cubed in the beginning. Then the negative 12y goes second. The degree here would be 3. Leading coefficient, number out front, would be 8. And there are 2 terms, so again, this one would be considered a binomial. Okay, we'll stop there for video 1.